All right, so we want to see what a vector is. So in school, they use I and J to represent vectors. So if they ask you what's a vector, the vector 5i plus 6j, like you said, 5i plus 6j. So this vector. Now, what's a similarity between vectors and Cartesian coordinates or points, or x comma y point, where on your graph you can plot the x comma y point? Is very, very similar. In this case, I here is the x-axis. So your 5 there is your 5 for the x-axis, and your 6 there is the 6 for the y-axis. So if we go and plot the point 5, 6, this is the point here. We are using Desmos.com, a graphical calculator, to do this. But then this is just this point 5, 6. But in vector, it is an arrow from the origin terminating at this point, like this. So this is a vector. So a vector is a quantity that has what? Magnitude and direction. So in this case, to express that, you say 5i, 6j. But can we express it in terms of what, how you differentiate it from scalar quantity? Yes, you can differentiate it. What is the distance? What is the magnitude of this? What is the length of this line? And what is the angle of this line? So this is what we can find. The length of this line is what? If you go and complete the right angle triangle, this length here, from here to here, this is what? That y distance, which is what? This is your 6, right? And then if we come and complete from this distance right to the origin, this is what? This distance is your what? It's your 5, right? So, and now we have what? A right angle triangle. So what is the direction of this line? The direction is just this turn that we make here. This turn is the angle. So we need to calculate this angle theta, and then we need to calculate this length here, r. Now that you have a right angle triangle, so what do you use to calculate your r? Pythagorean theorem, which states that what? R squared should be the same as what? 6 squared plus what? 5 what? 5 squared. Then from here now to get r, you have to find what? The square root of both sides. Then r will be the square root of 36 plus 25. Now we're having a calculator here. We can just use that. You can say 5 square square root. Let me see, SQRT. Do you have? Yeah. And then we do 5 times 5. 5 in bracket. We can just use bracket to say times. In bracket, then plus 6 in bracket 6. That's times. Good. And our answer is 7.81. So our R here is 7.81. So this vector has a magnitude of what? 7.81. So that is the magnitude. But now what is the direction? We've calculated here, the answer is 7.81. So what's the direction? The direction is the angle. So I can come here and I put a direction like this. I say angle, you know that this is a symbol of angle, right? Angle something. So magnitude 7.81, and then the direction. And since this is a Cartesian, we read the direction from the x-axis. The angle turned from the x-axis. Now that we know 6, we know 5. Opposite over adjacent is what? Opposite 6 over adjacent, what's that? 6 on 5. Yeah, 6 on 5. So, but what's that? Opposite over adjacent. Opposite, that's tan. Very good. So tan of the tangent of the angle. So you say tan of that theta equals 6 on 5. So how do we get there? How do we get the theta? The theta is what? Arctan, the opposite tan, right? called the arctan or the tan inverse. So the tan inverse is what? Tan like this, and what? -1 like that, all in bracket what? 6/5. And you can use your calculator. Since here we have a calculator, we can find that tan inverse. So we come here on Desmos, we click here, and let's see our calculator down here. Our calculator is down here. We go to functions. We click functions here, and we can see tan inverse. That's that tan inverse. And then there we just put 6 divided by 5, and we have 0.876 radians. Yeah, you were shocked to see the 0 point something. This angle is much bigger than that. It's not 0 this degree, but that is in radians. So you have to take that answer and divide it by what? How do you change radians to degrees? You divide by pi and multiply by what? 180. 180 up, pi down, or 360 up, 2 pi down, right? Right? Okay, so you do in bracket 180 divided by pi, which gives you pi. And now we have it now in degrees, 50.1. So now our angle is 50.1. So your total vector now becomes 7.81 magnitude at a direction 50.1. This is what a vector is. You see, when they say vector has both magnitude and what? Direction. So that's what they mean. But you see that instead of you expressing it like this, magnitude and direction, you express it as what? 5 in the x direction and 6 in the y direction. Yeah. So you express its direction in two directional framework, right? You have a framework. So that's your framework, 2 dimension. The x dimension, 6 steps. The y dimension, the x dimension, 5 steps. The y dimension, 6 steps. But that is not, that does not really capture one value, magnitude and direction. What captures that is called the polar coordinates. The polar coordinate, which gives you what? The radial distance and r, and what? The angular turn, theta. So instead of expressing it in terms of rx, x, y, we can express it in terms of r theta, which is just very, very easy. Since you know your trigonometry, you can use tan to calculate your theta. You can use Pythagorean theorem to calculate your radial distance. All right. Now we are done with that. Now look at a case like this. Look at a case like this. Okay. So we're done with this. We can clear this. And let me introduce something new. Okay. All right. Now let's get another point. Let's get another point. Give me another point. Give me another point. 3i minus 7j. Okay, let's see how that goes. 3i minus 7j, to plot that is just 3,7. We label it. Oh, that's plus. You said minus. Okay. -7. Let's do something like this. Let's do 10i. Let's do 10i, and then let's do 8,2. Let's just do 8,2. Let's not go that far. Yeah, this is where, yeah, 8,2. So this 8,2. All right. Now this is very useful. This is where you have to pay attention. Pay attention. Are you there? Are you there? Are you there? Pay attention. So this is 5i, 6j. And then this other one is 8i, 8i comma 2j. So let's say this is point what? P, or vector OP. This is vector OP, and then this is Q. This is point Q. So this is vector what? OQ. You put arrow like this. Then they ask you now to calculate what? PQ. Calculate PQ. They want you to calculate PQ. Okay. Then now, PQ now means from P to what? To Q. But this is how you go and draw it. P to Q. This is a vector that you will draw, right? PQ. But, and then you calculate it. The way you calculate it, what will it have? It will have its own, when you calculate it, it will have its own I value and its own J value. All right, so in this our case, let's come and see. What is our P? Our P is, what's our P, Aquila? And what's our Q? 8i plus 2j. Then now you want to calculate your PQ. And mind you, PQ is different from QP. QP now will be what? QP will be from QP will be what? From Q to P, right? The opposite direct. Okay, then let's see what we get here. Let's see what we get here. Give me PQ first. What is PQ? From these values, what is PQ? This is Q, this is P. What is PQ? Calculate, what is PQ? Aquila, this is Q, this is OQ, and this is P. 3i minus 4j, correct? Because you have to do 8 minus what? 8 minus 5, you have 3i, and then what? 2 minus 6, that's negative 4j. So we should be able to plot 3i minus 4j. But why do they say it is this one? This one going like this, 3i minus 4j. Why did they say it's this one? Why is this 3i? Why is 3i minus 4j hanging in the air? Hanging in the air, whereas all other, this is the most important thing, and you're sleeping. 3i, why is 3i minus 4j? Why is it hanging in the air? Why do they come and say if a vector goes OP and another one goes OQ, then from P to Q directly is the difference? Why do they say that? Why can this function hang in the air? But let's see. The problem is that you are still thinking I and J. But if you think what? If you think I and theta, then you'll get it. What is a vector? Magnitude and direction. What is a magnitude? What's the length of this thing? We can calculate the length of this thing. And then which direction is it pointing? We can calculate the direction with respect to what? The x-axis. You see that the direction will be towards the negative. Or if you want to turn the other way, it will be around 200 and what? 200 and more than 270 something, right? Yeah. If you turn here, it's already more than 270 something, right? Almost 300 and something, right? Okay, so now, but you say, sir, how do we label this type of vector? Yeah, you see the way this vector is? This is what you should do. This vector is exactly, as you see it, complete a right angle triangle. If you complete a right angle triangle like here, I should use complete a right angle triangle like this, and then here. You will see exactly that this x length is what? 3. This y length is going where? Going down. You see, did we go right? Yes, so 3 positive. Did we go down? Yes, how many units? Will be exactly what? 4 units. We went right 3 units and we went down 4 units. So even though we are drawing this vector in space, it's just like we are shifting. So what do they do normally? Normally, if we want to draw this vector in our Cartesian plane, this vector will just be represented by what? 3 comma minus 4. 3 comma what? Negative 4. And it will be the point. We label that point, but let's now, this one is a scalar point, but now let's turn it now into a vector. You have to just come now and draw the vector from the origin, and this is that vector. So it's a vector that we have just displaced it. It's a vector that we have just displaced it. Now, meaning that, how do you do the difference? The difference is done like this. Let me show you how you do difference. You see, the way your teachers are saying that, you know, the teacher taught you how to, if you have a vector like this, the difference is like this. They taught you like,
if you have a vector OQ and OQ, PQ is equals to OQ minus OQ.
yes. But how do you see visually? If I have a one vector like this and another vector like this, okay, what is the difference and what is the sum? If we go and complete their, for example, if you go here and you complete a parallelogram like this, you complete a parallelogram of these two functions. They did not teach you that. If you complete a parallelogram of these two functions, then we have 2 diagonals. We have 2 diagonals. One is what? One is the leading diagonal, and the other one is what? The lagging diagonal. One is the sum of the vectors. One is the difference of the vectors. They did not teach you that. Then now you learn it here. So this one is the difference, and this one here is the sum. Then how do we sum vectors? You sum vectors easily. You see, how do you, if I say 4 plus 6, you have to count 4, then after 4, before you go and add what? 6. So vectors are also like that. Plus their direction, everything will go smoothly. If I say this vector plus the other one, you go, this vector, you finish. This other vector from the origin is like this. But you have to go and add it what? After what? After the first vector. And then you will learn where the sum is. Are you seeing it? This vector plus that vector, it gives you now the sum of the vector now from the origin is what? This vector. Are you seeing that it is this plus this? Then what is difference? Difference now is take this vector, you do this vector minus this vector, right? But what is the minus of this vector? It's in the reverse direction. The minus of this vector is in the reverse direction. Then now you can do what? Plus. It's like 3 minus 4 is the same as 3 plus negative 4. So take the second vector and negate it, and then you add. So now how do we add? This vector is going this way, right? So you add like this. You just add simply like this. You take the first vector, you go, this principal vector that I've asked you, minus, you add now. It was going this direction, right? Yeah. So you add the same length. The same length. It has to be that part, the same length. And then at the point that you reach now, the answer now is what? The answer is from the origin now to that point. So this becomes the difference. And you see that this is the same as this. Yes. So depending which one you are taking to do the minus. So basically that is what we see here in our demonstration. That if you want the sum, if you want the difference is this. But what does it mean? It means that after I I walk the Q because PQ. So it's Q minus P. So first I have to walk what? Q. Then I have to do the negative of what? The negative of P. The negative of P is what? Is this vector. So I have to start counting it from the end of P. So I count it from the end of P towards its direction, you see? So this is what? Q. The negative of P, this is P. The negative is this direction. But you have to start counting it from the end, where you have ended. Then now you see that you have exactly this vector. Yeah. Which is still this same parallelogram there. So, but what a lot of people confuse in this notion is that the teacher says, oh, from the tip of this, yeah, because of the label, this is OP, this is OQ. So PQ will just be start from P and draw to Q. Yes, that's a visual of the length and also the direction. But then if you want to draw it back to the origin, you just have to do what? Displace it. Keep the length and keep the what? The direction. You see that? You will come in. Actually, that is a vector that you draw finally. Finally, you draw this. You will not draw this. There's no way to draw this because this is not the origin. This is not the origin. Yes. But you can draw this using what? Using the radial distance and the direction. But even if you use the radial distance and the direction, it's like at that time, you find out that for a vector, the starting point of that vector does not matter. A vector is what? The magnitude and the direction. Yes. Just give me what is the magnitude of that vector and which direction it is pointing at. Then in space, we can have some other applications where a vector can, because if you do some vector applications in the future, if you understand what I'm saying like this, you will really understand the vector direction of the future. For example, a flow of water. Water flows like this. Water flows like this. A pool of water. Yeah, if they put like this. Okay, what do you understand here? I understand that if this is water flow, it's water flow at every point. So at this point, it means the speed is faster because of this magnitude. And then it is flowing towards this direction. At this point also, there is kind of like uniform speed. And this speed, this one, the speed went down a little bit. The speed increased a little bit. It decreases a little bit. Here, the speed has dropped. So I will know that if you give me like a vector representation of flow, magnitude and direction, you can know where the river is flowing. So we can use vectors to do what? To explain river flow. So at this point, the speed is not high. At this point, it means beginning this point, the speed is high. Yes, at this point. So this length, then at this point, maybe I come and draw another one. It means the speed is slow. So this distance, it does not mean that it flows here to here. No. It means at this point, that is the representation of the what? The speed at that point, where the tip is telling you that point, and then the distance is telling you the strength of that speed. But then do we call it speed here? We call it what? Velocity. So are you understanding how vector comes now to model real life using these arrows like this? Yeah, so if you learn vectors, you did not really appreciate it like this. Yeah, vector is something very, very, very easy to understand. But if the teacher doesn't explain, giving some of these examples, it will be very hard, because this was a question that they asked Aquila. They gave them the I and J's, asked her to go and calculate PQ and all that. If you calculate it, what does it mean? What does it mean? What does it mean to subtract a vector? To subtract a vector is the same as this plane. So Aquila, 5,6. What would be the negative of 5,6? It will just be exactly what? Negative 5, negative 6. And then if we go and label it, you will see that it is, in terms of vector, okay, in terms of vector, this one is this. Then the negative vector is on the opposite direction. So this is the negative of that vector. Yes. So that is negative. So if you ask me to find PQ, it's like you have asked me to add to add a Q to negative P. Yeah, so this my Q is here. Then my negative P now is, I first go my Q and then add what? Negative P, which is this negative. But it's like you move it, you are adding it at the tip. Because vector movement is complete movement. I go P, Q, and then I add what? Negative P. This is negative P. Add it back from that tip. Just like we know that 0 to 4 is 0 to 4. 0 to 8 is 0 to 8. 8 is 0 to 4. I mean, 4 is 0 to 4. 8 is 0 to 8. If they say 4 plus 8, you will not come and do 0 to 4, you have 4. And then you come and start again from 0 to 8. No, you add the 8 after the 4. Yeah. So your vector is just vector addition, vector subtraction is the same as what? Scalar quantity addition and subtraction. You add at the tip. You add at the tip. It's just that, but the vectors now they start having what? Direction. Because if you were just adding, imagine you were just adding this vector after this vector, then you just add it straight. The line will just be what? Straight. But here you are not just adding magnitude, you are adding also what? Direction. Yes. So you see that vectors now become an interesting way of adding things. That it does not just sum directly. You can have a vector of 100, the radial distance is 100. Another vector, the radial distance is 100 too. You add both of them, it gives 0. For example, a vector plus itself plus its opposite is what? 0. Yeah. P plus negative P is 0. Even though both of them they have like good magnitude. So because you come and add a negative P, but at the tip of P, you add a negative P and then you land back at 0. So that is the vision of vector. That's the vision of vector. And again, one thing that I tell Aquila here is that they can give you anything. This is one thing that I don't want to see that repeat itself again. They say a vector is 2 plus A, all in bracket I. Oh my God. You have done BODMAS. Then here 5J. And they say A is what? A constant. This is just a mathematical expression. What is the negative of this vector? The negative of this vector is what? Negative 2, negative what? A. All in bracket what? I. Here, if you want to say plus, and then here you have to become what? Negative 5J. Or you just put minus 5J because plus minus is the same as minus. Like that. So that's the negative of this function. So these are things that should not be bothering you, because if they say a negative of something, your negative is applying everywhere. And that's why if you want to do it, if they give you a function like they say 5i plus 6j minus the other one, which is 8i plus 2j, you have to put this one like this, minus, and you put your thing in bracket, because this is your 8i plus 2j. You put it in bracket like this. Bracket helps us to see things, because this is a vector. You are subtracting the vector. The vector is not just one thing. If it was one thing, you would just put your minus here, and your minus will just affect what? 8i. It will not affect what? 2j. But your vector is this unit. So again, use your bracket wisely. Use your bracket wisely. So again, if not again, you can also draw that vector, because you see, they'll ask you go and draw a vector. At the end, they do that subtraction. The subtraction that we have done here, we see that our final vector is this, but it's just same like this, going from the end of P to this. Is that they are the same word, magnitude, and they are the same word, direction. That is the essence of the vector. Because in this case, your vector is not like it is modeling. You can still say, they say, go and draw the vector. You just draw it like that. If we're drawing it on a piece of paper, you draw one vector, the other one, you just come and draw the other one like this. That's the sum. That's the difference. But the difference now, depending, if they're asking you PQ, then you know Q is the positive one. P to Q. Q is the positive one. And then P is the one that you have to negate, because you do then OQ minus OP. But if they ask you QP, you do what? OP minus OQ, which will be just this same thing, but it will be the reverse what? The reverse direction. And that will be going up. But then to come and draw it here, it will be like from the origin here, what? Landing somewhere that is the same dimension here. So either way, that is what vectors are. But normally, if they say come and draw a vector, once you do your calculation will not draw this. Will come and draw again, but from the origin. But it's the same thing like this. If you are summing these two vectors, of course, the length will be here. It will be this vector here, then this one just what? Slide it after this one. Then now you complete here, it will be the longer parallelogram. So your parallelogram was not something that was taught to you just like that. Parallelogram helps you to understand what function you have. Leading diagonal and the lagging diagonal. The leading one is the longest one. That's the sum of the two vectors. The lagging diagonal is the difference depending where you are going. Yes. So again, I hope that Aquila, that this lecture under vectors will be helpful for you. So that is the Amira, when we talk about flow, you understood the power of vectors, right? When we talk about flow. For example, we are here in Google. Let me see how, let's look for fluid. Okay. Vectors in fluids. Pictures. Vectors in fluid mechanics. Or fluid motion. Fluid mechanics would be the same. Let's look at pictures. Good. Oh, no, AI pictures. Look at pictures. Good. So you see pictures like this. You see pictures like this. So as I see it like that, I just know it's a circular word, circular flow. Then now I can see the speed at different points of the flow. And I can see that this speed is higher than this speed. Yes. Or that from the inside going outside. You see, this is from the inside, smaller speed from the inside. As we are going outside, now what's happening? The speed increases. You see, just by looking at this, you have an understanding of vectorial representation of this flow. That here the speed is a little low. As we are going outside, these lengths are becoming what? Longer. See? So that's a very good representation. So circular motions, and that. Then even your magnetic field, you also understand it. Now you can better understand your magnetic fields. The magnetic fields, but they also tell that for your magnetic fields, if the field lines are closer, it means the magnetic fields are stronger because you have more lines, more strength at that point. And then if they are far apart, it means what? They are weaker. Yeah. So because that's the visualization of that one. Yeah. So because later you people will study a lot of, and then this is flow in terms of 3D. It's a 3D flow, not just 2D. So this flow is a 3D. But if you look at it also very well again, the arrows are there to tell you also the strength. Again, in the outside, it's stronger, and in the inside, probably smaller. Because these are points off from the outside. Then if you look deep, again, 3D, like spherical, and then this type of this thing, a rectangular coordinates where you have x, y, and z. So z now, let's say your xy is the floor of your room. Your z now is the length above and the length underneath. Yes. So, and because later in the future, people will go and be drawing this x, y, and then z. So if you just understand what vectors I can visualize it, then you will not make any mistake. You see that it's like the beginning of that vector is like the origin, and then the length of that vector is the magnitude, and where it is pointing is your direction. And it's the same thing here also. Xy plus x squared plus y squared plus z squared. equals what? I squared. The Pythagorean theorem also holds here in 3t. Yes. All right. So that is that. You can stop this session.